Ros.
Hey everyone, welcome to my talk about Java resilience. Before I start out, I need to turn on my clicker probably. And then it still doesn't want to work. Seriously? Take us hard, guys. Okay. There we go. So first of all, about me, I'm Renette. You probably guessed that already. I'm a technical lead at Intellect, also at a standard bank project, but a different one from Greg. And some days I am the chief dragon slayer in my team. In my spare time, I love reading fantasy books and enjoy playing board games. I'm starting a garden, and my real boss is this cuddly little lady. So what is this talk about? We all know production is an amazing place to be, and we all want to be there every day. But sometimes there are dragons. And to get our systems in a more resilient state, we need to find and slay those dragons. Let me tell you a story. You're fast asleep, or maybe you're lucky and just daydreaming, when your phone rings. On the other side is your boss or someone responsible for monitoring, and they tell you production is down. Your customers are angry and they're making it known on social media. My broadband journalist is breathing into your neck, and your boss wants an update every 5 minutes. So what do you do? In this talk, I will share some hopefully practical tools for you to be able to find the problem, reproduce it, and hopefully prevent it. Let's start out directly with finding the problem. The first thing is our Swiss Army knife, our application monitoring tools. This is a black box. APM stands for Application Performance Monitoring. It's this real-time monitoring system that your company pays big money for. It measures overall application performance and also individual transaction or request performance. And bonus, it can probably give you alerts so you actually know before Down Detector knows if your system is down. What I mean when I say application performance, it's a lot of these things Greg chatted about. What does your memory usage look like? What does your CPU utilization look like? Do you have disk space? How much is your JVM doing garbage collection? And transaction performance, things like response time, error rates, how much load you have, are there common exceptions in your code, and sometimes it can take snapshots of individual requests to see where in your huge distributed system things went wrong. So some examples of these tools, I have a lot of pictures here. The ones I've worked with are AppDynamics and Dynatrace. Azure Application Insight gets a notable mention, but there's lots and lots of different tools. Bit of a black box, but they're like your first point of call when anything goes wrong. Here's a screenshot of Datadog. You can see there's got some latency going on. There's some metrics here. There's dashboards. There's total load, lots of different information. This one shows AppDynamics. The nice thing we can see on this screenshot is how the requests flow between all the different microservices in the system. So that was our first stop, the one-stop shop, usually. The second thing is Micrometer Matrix, and I think I'm like the fourth person at this conference to talk about this, so you all get some metrics. So what it is, like you've heard before from Cornel, it's like SLF4J, but for metrics. It's got a bunch of pre-configured metrics for your JVM and for things like Spring if you're using Spring and other libraries. It's got many different bindings, so you include this micrometer in your dependency and you can export it to many different systems. Super easy to use, and because it's super customizable, you get great metric drill down. Generally, how we have this is you've got an application, it has a micrometer dependency, a specific meter registry. For example, you're saying my metrics need to go in Prometheus, so we need to export it for Prometheus. Then it exposes or exports the metrics somehow. It's got a bunch of predefined metrics and your own custom metrics. Then we've got our metric store. This has got some sort of database that uses time series and maybe dimensional, so you can drill down in the tags. You can ingest and store the metrics, and you can also query the metrics. This would be, for example, Prometheus. Then we've got dashboards and alerts. This can be separate from your metric store. It queries the metric store and puts all your things into pretty pictures. For example, like Grafana. Why do we want this? We've already got a big black box that we pay a lot of money for, so why more? First of all, it isn't necessarily separate. Some of the APM tools can just ingest your metrics. And a point I forgot to mention here is Prometheus and Grafana is free. So if you don't have the expensive big black box, you can have something at least. Then redundancy is good, even with monitoring tools. And in my experience, they fulfill slightly different niches. There are things you can monitor better on your real-time AIM tool, and there's things you can monitor better on Prometheus and Grafana. And the big thing is it's less black box and more customizable. You can have metrics for anything. Say, for example, you have like a super high volume service and you've got some cache going there. You want to know how many of your requests hit the cache versus how many actually hit the slow downstream service. You can have metrics for that. So that was tool number 2. The third one is logs. And if you cite internally, that's okay. I get it. Logs are kind of boring, but they're still important. But for your logs to be helpful, first of all, you have to correlate them both inside one application. And if you have a distributed system between all the different applications, you have to index them and make them searchable. You do not want to SSH into 20 different VMs and try to check the logs and correct through them until you find that one request that you were looking for. Your log should include important contextual information, but that's just your own logs. Sometimes we also need framework logs. And debug logs are important because if something goes wrong in your framework, that's probably something that you're going to see on debug logs. A notable example was one time in production, our connection pool somehow got exhausted and we didn't know how. But for you to actually use debug logs, you need to be able to change your log levels because chances are if you try and restart your JVM, that problem's going to go away and going to come back tomorrow. There's multiple ways to do this. One way is JMX, the Java monitoring extension that probably has integration into your fancy APM. You could just use HTTP endpoints like on Spring Boot. If you have some sort of config server or remote config source, you can use this. So make sure you can change those log levels without restarting Java. Now that we're getting to point 4, things are getting interesting. We're now at a point of things were broken, and I can see they are broken in my monitoring tools, but I don't know why, and the logs don't tell me either. So up next, we're going to look at thread dumps. Thread dumps are snapshots of the state of all the threads in the Java process. Some situations for why we would want this include your application, your web app just became completely unresponsive because there's no threads available to serve your incoming HTTP request. If you've got thread pools that got exhausted, if you have stuck threads, if you have some sort of deadlock situation, if there's a performance bottleneck or your monitoring tool is warning you about thread contention, or sometimes even if you have extremely high CPU usage. The unfortunate thing about thread dumps is this is a snapshot right now. Don't have an historical view. So you need to do this during the incident, or if you manage to reproduce the problem while you're debugging it. Or worst case, if you see a problem is starting to happen, but you can't pin it down, you could take it frequently at intervals and compare, so you can actually get a historical view of what's happening in your Java app. How do you do it? Luckily, if you're running on a Linux system, this is super easy. You just go kill-3 with your process ID, and there it is. There's also some tools that come with the JVM. You can use JStack or JCMD. And sometimes your fancy monitoring tools could also take the thread dumps for you. And in rare cases, you can do it programmatically. For example, Spring Boot exposes an endpoint that can take a thread dump for you. But you probably don't want to expose that in production. So you've taken the dump, and then you get this text file. So yes, it's text, so it's theoretically human readable, but it's way too much information. You see a sample format here, details aren't super important, but we need to analyze it somehow. I tend to use online analyzers for this. I like to use FastThread, like you can use it for free with some limits. Don't like you to pay, but you can use it for free. It tends to give you the relevant information in a nice summary. You could also use Java Visual VM like Greg showed, and many IDEs can even analyze the thread dumps for you. Not doing live demos for the sake of flow and time, so I just have some screenshots for you. There's a little thread dump I took. You can see it tells you how many threads there are, a nice breakdown of the different states they are in. And then here it tells me, you've got so many threads with an identical stack trace, and all of them are waiting or blocking on an object monitor. And then you can go look at the code from here and go like, okay, so why would all my code block here? So that was thread dumps. The next tool I have are heap dumps. And before I go into deep detail, I need to say, yes, memory leaks can happen in Java. I've encountered it multiple times. So what it is a snapshot of all the objects in the JVM heap at a certain point in time. We're still dealing with snapshots, but of a slightly different nature. Why do we need it? If you've got memory leaks, if you've got high memory usage or out-of-memory errors, if you've got weird garbage collection patterns, for example, if you observe that your garbage collector is constantly performing major GCs, then take a heap dump. When you do it, same rule, still a snapshot. So during the incident, while you're trying to reproduce this, or at fixed intervals so you can compare what's happening. How do you do it? This one's a little bit trickier than thread dumps, because especially if you're running with special users, there's some extra steps you have to follow. But the basic idea is when you start up your JVM, you add this command line option to tell it, hey, make a heap dump when you run out of memory. This is important because if your JVM is already dead, you can't take a heap dump. You can use the JMap tool. This is the one we use most frequently. You give it a process ID and tell it where to save the file. Or you can use JCMD and give it, once again, also a process ID and the heap dump. Same rule as earlier, we need to analyze it. This time it's a binary file, or we can't even look at it in a text editor. Java Visual VM can do it, not the best in my experience. The tool I stick with when I'm analyzing heap dumps is the Eclipse memory analyzer, or Eclipse map. Some IDEs can also do it. I only found out like this week. Apparently IntelliJ can analyze heap dump, so that's cool. And there's also various online tools, but I haven't really tried them. So you can see this is a screenshot of Eclipse map. This is when I opened up the file and it was like, hey, so I can generate all these reports for you that it shows at the bottom. First step is usually the leak suspects report. It looks something like this, where it shows you like a nice little pie chart of what objects are taking up memory that it thinks could be causing leaks. And then it tells you, so, there's this instance of leaky cache, and it's inside it is a concurrent hash map that's holding out a lot of memory. If you think you have a memory leak and you found a concurrent hash map, you probably found your problem. Any kind of map, actually. There's also some other useful reports. So this one shows the dominated tree. So that's about objects that holding onto the most things. Doesn't necessarily mean it's a memory leak, but it could be. And just the top memory consumers. But there's lots of different queries and tools. And if you need to analyze heap dump, I recommend just play around with the tool and see what all the different reports and tools does. Can't hurt anything. That is memory dumps. The next one is Java Flight Recorder. Java Flight Recorder is a profiler and it gives you a lot of JVM diagnostics. Up until, since Java 11, Java Flight Recorder is available with OpenJDK for free. Before that, it was a commercial feature in Oracle JDK. It gives you monitoring diagnostics, a lot of what we've already seen, but another option if you don't have APM tools or Matrix. And it has a profiler, which is what I want to look into it. The great thing about Java Flight Recorder is it's got low impact. It's got very little impact on your running JVM because it does a lot of asynchronous things under the hood to prevent impact. How do you do it? Similarly to heap dumps, you could just start the flight recorder when you start up your JVM, but that's probably not a route you're going to go, because if you knew problems were going to happen, we would try to fix them, right? If you're in a more reactive frame of mind, you can use JCMD once again to start and stop the flight recording. There's a bunch of other options, including setting limits for the file size and how long it should run. If you're interested, you could look it up. And after you're done with your flight recording, whether you use the JFR stop command or stop your JVM, you get this .jfr file. So what you do with it? Obviously, we visualize it. The most common tool for this, I find, is Java Mission Control. It's not part of the JDK, but you can download it from Eclipse or Zulu JDK. All of those OpenJDK websites also have Mission Control. Some IDEs can use it, can analyze it as well. And there's various flame graph viewers or flame graph generators online. What you get out of the profiler is this thing called the flame graph that looks something like this. The idea is that it shows you how long methods took in the stack trace. So our x-axis, horizontal here, is how long a method took. So the bigger blocks are methods that took longer. And the vertical axis is our call stack. So which methods were called. Here we have a controller from our application that calls get busy, and then it calls shuffle, and then it calls sort, right? So that is a flame graph. Here's a little bit of a drill down. If you struggle to read the small text, maybe it just shows how the call stack looks. So the great thing about flame graph is when you've got this high CPU usage and the thread dump isn't showing you anything, a flame graph might help. Your profiler might help. If you've got any kind of performance bottleneck, your profiler will probably help. Now we've got the basic toolkit for finding the problem, but we can't always find the problem right now. So talking about reproducing the problem, we've got load tests. And this is the most important thing when you're trying to reproduce anything, because problems don't happen when there's one request per minute. Problems happen at the end of the month when everyone's furiously trying to get into the banking app at the same time. The idea is, yes, we can do load tests, but to make our load tests really good, we need to do them under non-ideal circumstances. When a downstream service slows down, or the network acts up, or there's high error rates from other things. Non-ideal circumstances, keep your load tests as close to production as possible. We are trying to reproduce the problem after all. Greg touched on this as well, but figure out what are your goals. What do you want to know? Do you want to know how much load the service can handle? Do you want to know at how much load you start to break your SLAs? And look closely at the results. It doesn't matter if you have this amazing 1 millisecond response time, but all of them are errors. That doesn't help. And now we're starting to get to the real important part, which is be proactive. Do some load tests before you deploy to production, maybe. Load tests aren't the easiest thing in the world. But making production is easier said than done, especially if you work on a big distributed system with lots of components that's outside your control. Just because of sheer scale, like, sure, you can scale your components to match production, but the network and those third-party services probably don't match production in your testing environment. Getting data, you can't just use one test user to do all your load tests because your beautifully optimized database is going to cache it for you, and maybe even your Java program. Network, all the things that go weird in production networks don't go weird in SIT networks. So that's why things break in production a lot of time. And I've already mentioned downstream systems. There are a lot of different tools for load testing. I tend to stick with JMeter just because it's simple and I know it. But if you're trying to run large distributed load tests, JMeter does start to have some limitations. I'm not going to go into what's shown here. Greg already talked about load tests extensively. I mentioned earlier that we want to have non-ideal circumstances when running load tests. And the way we get this is to get some tame dragons, aka chaos engineering. I'm not going to talk about chaos engineering exhaustively. I just want to mention one tool, and this tool is called Doxyproxy. Doxyproxy comes from Shopify's chaos engineering suite, and it allows us to simulate a bunch of different network conditions and network problems. Since we work in distributed systems, a lot of the time, network has a huge impact on how our applications perform. It's got a CLI plus a proxy. You can start up the proxy and then use the CLI to change it on the fly. You don't have to restart everything every time. And the thing I really appreciate about Doxyproxy is it's usable regardless of your environment or your deployment model. If you're running in some sort of containers, cool, there's a Doxyproxy container. If you're still running on-prem outside containers, you can just run Doxyproxy standalone. It's very nice and flexible. Some examples of what it can do include adding extra latency to delay everything, slow down everything. You can limit bandwidth in your network. You can delay upclose. This is an interesting one because sometimes these requests hang around and then things run out of resources. You can close connections early after some sort of timeout or after a certain amount of data has been transferred. You can easily simulate TCP resets. And you can also slice up TCP packets and add some delays in between the pieces. Now, that's good and all, right? But we're being super, super reactive so far. What we actually want to do is prevent the problem. I'm going to go through this super quickly for the sake of time. So the first thing we have is timeouts. If you take one thing away from this talk is put timeouts on everything where there's network involved. HTTP, database, message broker, any type of put timeouts everywhere. We don't want things to be stuck forever. The next one is connection pooling. Connection objects tend to be pretty expensive to create, so reuse them wherever possible. Once again, in any network component, not just Java apps, any things you have control of where you can enable connection pooling or connection reuse. Most common in databases, but also high impact on things like HTTP clients. The third item we have are circuit breakers. If things are going wonky, let's fail fast and shield our downstream systems from our customers furiously smashing the retry button. Bulkheads, if a dragon burns down one half of our castle, let's install some fire doors and make sure the other half doesn't burn down as well. And Fallbacks, this one, just if you can, ignore some non-critical errors. Give the users some interaction, for example, by using cached data or default response, so they can at least have some interaction with your app while half the functionality is broken. So I've attempted to give you a lot of tools, but there's no silver bullet. In the end, to use any of these tools effectively, you need to know your system and understand your tools. If you wanted to play with any of the tools, you can go clone this project that I made on GitHub. There's a little Spring Boot app that can simulate memory leaks and two of the thread-related issues. And that is the end of my presentation. Thank you for listening. Are there any questions?
Yeah, hi. Do you recommend, like, if you want to use like this type of load testing, resilience testing, do you typically do that in a test environment, or do you set up a specific environment where you do this?
It depends. The one thing I can say is don't try to run the load test from your local laptop. Your VPN will hate you. Corporate VPNs do not like load tests, and even if you're like, regardless of what environment you have, I like using the test environment because everything's already there. No need to do something dedicated, but you're probably going to want to run this load test from multiple places, just because the limiting factor of the outgoing network on one VM. No more questions. Then I guess thanks for listening again, everyone.